Correct. Uh, they will have special guest training. So, so get maybe officer. So here, more or less, here. So training our strategies, experience and knowledge. That's it. So please welcome Professor Mark. Small group. Nice to meet you. And as a mom, I just before I introduced by Professor Han, I have something about the 4 years in Korean Navy as a leadership design. And I experienced many kinds of ship design and after I retired about 10 years ago, I moved in Paris and carried out many related to research programs. And especially today, I'm very happy for many young people that I can introduce my work design. Work design is very similar to commercial ship. Basically, their architect's point of view is very similar. So as I know, the Professor Han covered many things about leadership design. And so I I dropped many model design cards. In the States, um, one towards the level design. So it's very complicated, very uh, profound knowledge and new hearing concept. But today, in a short time, I covered the leverage design characteristics and some design trends, current or future. So I hopefully I want you to remember what is the right design. Mm, some the beautiful day, some level officer professor mentioned about that. So you can remember I very okay. During my lecture, do not hesitate. Raise your hand and press. Okay, I can answer anything because I discussed many things, many type of script. So and mm, I hope you can take a job for these kinds of design and technology. Next, I'd like to what's design characteristics. Uh, what is the working? As I describe this lecture, um, warships defines for fighting and fighting support. And function is the fighting, floating, moving. That is the basic uh, requirement for that. So warships acts like home corners for fluid component. As you know, for especially for Navy, warship is just like home. Um, at the ship to sleep, eat, and work, and recreation, and many things. So the ship designer have to um, consider about that. And watching this complicated military mission and long-term facility. Okay, what it is for fighting, so you need satisfy the complicated military needs. So was the most complex and fascinating engineering systems. Okay, let's move on. Classification of warships. Normally, there are many kinds of the classification method, but the United States, US Navy classify like this categories: warship classified the surface ship, submarines, and surface ship, combatant ship, mine warfare ship, landing warfare ship, support ship, and each category ships. So divided by the main working names as you covered before: aircraft carrier, amphibious ships, cruiser, destroyer, frigate, corvette, and patrol ship, and mine laying ship, mine hunting ship, mine shipping ship, shipper, mine hunting and shipper, landing, landing ship tank like blah blah blah. And the submarines are attack submarine and nuclear submarine and bursting missile submarine and fighting missile submarines. So most of the ships classify like this, and you can consider many the videos or many uh, pictures you can see, and oh, what is the category which can classify that? Warship operate in group. For example, aircraft carrier cannot exist itself because the aircraft carriers can carry out many things. For example, chips, maybe. So some of the group we call the task force. Carry strike group, aircraft carrier strike group, CSG, and anti-air warfare, and anti-submarine warfare, and anti-surface warfare, amphibious ship. Amphibious ship is for Marine Corps to 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 attack the land from the sea, and the mine warfare, and then anti-land warfare. Anti-land warfare only the ship gun firing or missile attack, not amphibious. Okay. And what is the difference between the warship and the commercial ships? You see, they see the pictures. Commercial ships for platform, simple platform and the leveraging and the ship crew and the performance. Warship is this commercial ship function plus combat system, warfare, and the combat personnel and the surrounding the popularity and the interaction. Sure. Okay. And the warship and commercial ship was difference. Typically, warship commercial ships designer improve the existing ships because of most of the commercial ships are standardized and some modern designs. But the warship is different. Developed new ships because they faced the new battlefield environment and technology development. So what is more faced and more challenging and some cutting-edge technologies. Especially requires a little higher technologies, mobility, speed and combat capability and CKP maneuverability because the warship is the maneuvering hard turn time and the speed and like that. And we use voice and vibration and survivability, stairs, etc. And Warship is needed for system integration. First, functional integration. As you can see the picture, Warship is divided by three categories: platform, oil, natural and electrics, combat system, and special performance. Normally, the commercial ships only need a platform, but what was the combat system and special performance are needed. So three components integrate well. And the combat system for warfare at sea, you can see the surface warfare and the anti-air warfare and the submarine warfare. And inside that, there are many kinds of warfare are needed. And for that, many sensors, many weapons are installed in warships. Okay. Question? If you know questions, let's go on. Warship acquisition procedure. We two categories: combat system and platform. Combat system, R&D and design, they continue, and the platform also concept design and base design and detail design like that, and all together, mutually complementing and the interface and integrating during the design and design and the R&D from the beginning of the project. We can so mutually interface and integrate closely. And unfortunately, as I know, the commercial ship takes about 6 months or 3 months to make one ship. For the start, is correct. Unfortunately, the warship takes about 10 years. Because what warship is the developed first, not the existing ship improvement. So because the normal process is like that. Physical study, concept design, and basic design, construction, and operation support. So it's not from the beginning of those project, they carry out the feasibility study. They lead the feasibility study in-house study and design. It takes about 1 year. And concept design, the data of Navy. After that, we have the requirement capability as a top level requirement document is produced. And basic design takes about 2 or 3 years. They two categories: preliminary design and contract design. After that, the design stage produce the shipbuilding specification for construction detailed design. And detailed design and construction altogether, it takes about 4 years or 3 years. After that, all from the basic design and detailed design shipyard lead. So totally about 10 years or 8 years. Under the pictures, U.S. Navy warship acquisition process, very similar in Korean and Navy. But in this currently and the future, this acquisition process is very short because the technology is changed quickly. So every day, every country try to speed the acquisition process. This is the also performance change rate phase. As you can see, the performance X axis is the time, Y axis is the performance rate. Early stage of the design, even though the cost is very small, but the performance is very high. So early stage and preliminary country design stage, most of the performance are fixed. So the designer and the R&D people consider this stage of the important. Okay? So, especially the performance of the detailed design, detailed design, most of the performance are locked in. The others are manufactured by some chip. And this is some stakeholders related to the worship design and the construction. This typically this influence stakeholder operation configuration. As you can see, the those joint sheet of steps and the Navy and ADB, Agency of Defense Development, and SCAPA, Defense Acquisition Program Administration, and shipyard, and CRIP, combat system makers, and equipment system making, all together, closely and interface and communicate well. Because even though each stakeholders have some that their goals, but even though some different goals, all together communicated interface, then another goals can be compromised. All together, for example, the KAIST, all together support the technology and R&D research. Okay. You can, if you want some West design and research, you can work some of the activities. Now, what is the name requirement for warships? The requirement defined by the top-down strategy. For example, what force for Navy or Air Force and Marine Corps like that, what force? What is total ship requirement? And what system weapon system requirement? 11. So top-down requirement is specified step by step. And also the requirement of capability ROC specified like this operation capability review and threat, mission scenario, and required capability, additional schedule, support system. This is very complicated and some specified many things, even though for example, this is the commercial ship design requirement. Very simple. And all field commercial ship all is take money. That's it. So for example, ship type, shipping, cargo, service, dimension, irrigation for general for national club, those cases, blah blah blah. Second stage of the concept design, the designer produced the top level requirement for worship design and developed the mission requirement, mission, manning, interoperability, and operating environment. Electron requirement. What is electric ship rate, maximum speed, cruising speed for adaptability with the iris, etc. And system requirement, combat system, weapon system, survivability requirement. As think some three components of that. Normally the price of the washing is the normally combat system is about 60% price, and special performance about 20, and the platform is about 30. So combat is very, very expensive. So the requirement also the capability, the combat related parameters are important, like vision and capability, efficiency, like that. And there are also mission requirement, platform requirements, system requirement is combat system, and survival and special performance. Any question? Too speedy or too slow? Fine. Can you understand or no? You understand all the genius guys. Okay. Next. Community also worship designer have to have the philosophy, and that is the priority of the designer. According to ship mission and the ship designer point of view, there are many kinds of the philosophy. What philosophy we should design these ships? Give you some example. This is the when I was young, I was designed the destroyer. At that time, I set up this kind of design philosophy. First, combat capability and survivability and man reduction, operability, acquisition cost, adaptability, and the principle of operation, maintenance, order. This is an example, but in this currently or in these days, maybe combat capability, survivability also is good. Manning reduction, adaptability is very important. But in these days, the crew is like on board. So we have to lure some young boys for that. Adaptability is very good. Right? So every time I mention about our senior, the junior designers, you have to consider adaptability. For fight, man is important. Okay? Science product is you also studied the design product from Professor Han, right? So this is very similar, but as a point of the viewpoint is some many considerations and are merged and considered systematically. You say the concept design, the surface more concept, and in the core circle is some detail design. Okay? And fortunately, our Korean Navy have our own rule and standards for warships. When I was in the Navy officers, I tried to make this rules and standards for Korean Navy standard and the Korean rules and naval vessels, surface vessels, submarine vessels. So here we develop and some fix some different new ideas or new requirement. Now we can jump to some details. Platform design. Basically, the platform design is very similar to communication. What considers worship platform design, mission warfare, ship speed, combat system, flight exercise, and maneuverability, security, intake and damage stability, and state design. These kinds of the requirements are very different types of ships. Very different types of ships because, for example, the front deck side, this is very impact many things to ship the control and some deck side and some platform. So right hand side, we can see the some triangles. See the x of this x axis the buoyancy and z axis the power limit and the y is dynamic. For slow ships, the buoyancy come from the most is the hydrostatic force, and speed ships also have the most back from the dynamic lift force, and air cushion vehicle is come from the air cushion pressure. So axis is the slow speed and low speed on the y and the z axis. Okay. There are many various kind of hull forms in the air environment. I think that you can see some pictures before. Everything before. First is the mono is a very typical hull form, so monohull. This is some kinds of our Korean name. Some I know. Hull. The second is the catamarans. I cannot know the name of this. What you know what is the advantage of the catamarans? What do you think about? Wearing the one
Very normal. I'm guessing that a customer needs to be like um called more stable in certain water.
so important. For example, it's like the ship design can see why that we have to choose before the design early stage of the design. Why we consider the monohull, catamaran or trimaran. For example, the catamaran is the large deck areas, so many flights can let the take off and land, and the stability is good. And but the problem is the some structural situation is not good because there's some inside the hull, some the high waves come and some the twist movement is there. So and the driver and the this is the surface effect ships and this air cushion vehicles. Air cushion vehicles are two engines. One is the for propulsion. One is the some in terms of the air cushion vehicle, inflatable air cushion vehicles, so and SWAT ships. Young student, what's the conjunction of SWAT? Your English, what's the form? This is very also the twin hull. What is the SWAT ship is the some as you can see the small area, small surface area is very small. So we as you can teach by Professor Han, the resistance is the some friction resistance, wave resistance like that. This small surface areas is the not make the wave make reduce the wave make distance. So we send some SWAT ships and also take large deck areas and ice washes, hydrofoils, rigs. Anything before the about the being ground? No. No, the airplane is like that from the land to the flight is very long distance. But about very close of the land, if you fly, the lift force is about increase about 1.2. Many much of the payload can make that. So in the Russia and the Soviet Union, they developed wing ground ships. Many countries try to do that. For example, this is very useful for speedy ships and some the weapon and speedy and more payload. So and no wave distance. That was very good. I very interested person. And very many oil pumps station, very piercing ship, and petrol ship, SWAT ship, underground ships, coast petrol stations. Why the coast petrol ship is the different colors comparing others? Please.
Blending of the
Some protection.
town hall.
Because this ship is operated in the inland lake, so don't fly from the environment. So color, this is the inland ships, some almost similar to the mountain colors on the seas. The others are hatch grades. The ocean going ships are hatch grade colors. Okay. Okay. Next is the general arrangement design. Even though the commercial ships are generated by some the cargo and some cargo handling, it's important to have general arrangement design considerations. But this is the some different outside considerations, combat performance, sensor detection range, weapon firing coverage, ever sensors interface, test. Okay. For example, you can see that some Aegis class destroyers. There are many sensors on the deck. So there are many sensors and weapons interface each other. So we have to avoid some interface interference. So we will have the designer consider about that and certify the compromise which system. Okay. It's a long time, yes. And whole space arrangement considerations, some different floors, chain cameras, down in the stand, for especially the warship's fire zone precision. In case the warship is attacked by the nuclear and some nuclear, biological, and chemical weapons, there are many sections, but some sections pressurized to avoid the contamination of the sun. So we have many some fire zone, pressure zone we have to design. There are normally there are 4 or 5 zones. In case of some zone is detected, the others should survive. So bank or any auxiliary systems, this is the construction of the whole space arrangement. And the structure design is some different, and basically whole form design load black letters are same as the commercial sheet, and this colored letters are the for design load of the combat ship, combat environment, underwater explosion and air blast, fragment loads, overshoot effect, and aircraft landing. These kinds of the loads should be considered for whole structure design, especially the all the structural alignment should be important in case because of many points. If the ship is going to the ocean, there are big side of the waves, and this is some movement by the holding and sagging motion. Then there are many the first in these areas of the some alignment. So all the structural alignment is very good, and especially the environment is very good, very important, and high tensile still use the plastic hardened bulkhead and the box water and cover bottom is the, some features of the warship because in case of some state or some space should not be expanded to another bulkhead or another space. So prevent that, we make some glass hardened bulkhead and box waters like that. Oh, next is the survivability and underwater bone noise. This is very interesting pictures. The green color is the structural noise and an airborne noise, and the red color is the waterborne noise. There are three kinds of the noise here, especially the structural noise will come from the machinery and auxiliary machinery. Some the engines make vibrating, and they also vibrate some structure. They also, and after that they radiate the noise at sea. It's vibrational machinery noise, structural noise, and flow rate. When the ship is go speedily, then make the between the interface between the water and the surface, they make some flow noise, and sometimes the fittings on the openings they make also flow noise, and repetition noise also, and proper noise all together make the radiated noise effect. Because this radiated normal noise is URM is very important features of the environment. We have to reduce because to protect ship and to survive. And hardening design. and the combat system design. Any questions? Any questions? No, you can still working.
What's a shock hardening?
Shock hardening, oh, they're very good. In case this warship is here, some mines, torpedoes explode on the water. And the explosion, ship have to survive. So shock hardening the design is needed.
Oh.
And the combat system, normally the commercial ships only have the surface search radars. But warships are various kinds of warship, volume search radars, and long range, and multifunction radars, and tracking radars, and electro-optical tracking systems, and IR search and tracking systems. All sensors some the overlap and to prevent the attack. And combat system inside navigation system and weapon system, sensor system, and communication system all together, and the combat system management system is the manage and data commercialization and some tactics. Combat management system here all together, we should be designed and many sensors and weapons are integrated and installed in ship without the interface each other. This is very important. And total ship computing system. Okay, but now we are briefly give you some what design characteristics. Any questions? Never. When I was young, I studied so many countries, United States for what design, and UK and France and Netherlands. We all together communicate and study for watch design communication. Very similar. So I think even though the different countries here, every young boys have some attraction to your country. I think. If you work for some of the area of this watch design, so you can get the two things, make money and you attention to your country. Oh, now let's go to the watch design trends. Humble home wave piercing. And in the past, when I was young, this humble home wave piercing horizontal exist. When the problem is when the watch is going out, personally I dislike the watch because any ship is off. So this problem is humble wave piercing is they just like the knife edge, they cut the wave and they smooth it for. So reduce wave making, reduce returns, get the better CTP and the spreadsheet. Problem is to establish that options. This time is not also the make better these days. So this is warships. This is the commercial ships. So the large ships and small ships make this kind of warship. Next is a very important thing is the enhanced ship survivability. survivability is some to avoid or withstand from the volatile while performing missions. For ship survivability, three categories. Perceptibility. This is the simple defined to avoid detection. If you can see the more quickly, if you can see the first and long range the before the enemy attack, you can make the operate advantage. So susceptibility, you make the use of signature reduction, RCS, IRU again, and the reliable self-defense, jamming, detection, and deception and decoy tactics. Vulnerability. Once you are hit, you have to make the withstand the hit. So for to for survivability by hitting the journal design and within the component, in case some of the component is some of the areas hit it, another zone should be alive, and some component of the equipment, redundant component is ready. This is a vulnerability. So, and protection against hostile weapons. And third part is the recoverability. Once hit and damaged, you have to recover the systems, damage controls, damage recovery. For example, if you many things are fail through evacuation and escape should be well done. And for the more advanced technology, make the total ship survival design. In the early stage, from the early stage of the ship design, the designer should be considered the total ship design, TSS design. As you can see, the susceptibility, vulnerability, recoverability. First stages of susceptibility is very good, very high, and the step hit vulnerability here, and once hit, after recoverability, the performance is very high. So there are many attacks from the pieces, some just maybe attacked by some small unmanned ships. And use ship signature, radar cross sections. As you can see, the radar cross section is the sigma, is the ratio of the scattered and transmit ratio. These kinds of some signals in the radar scope, large RCS make looks this signature, and the small RCS should is even this is the right hand side is the DBG 1000 in the United States. This even though the 10,000 tons signature, as I know, the small fishing ship, small. By the inclination of the design, shape design, and the many observing materials. Typical RCS design and infrared induction system. Stefan Boltzmann wrote total gathering energy emitted is the force power of the temperature. There are about the frequency, the near infrared and middle infrared fiber. This pair is very good. For example, middle infrared is the most is the result from the exhaust flow, and any missile search and follow this exhaust flow. And far infrared is the ship's surface, for example, in the sunshine hitting the ship surface is hitting, then they make more far infrared. For reduce the far infrared reduction, MIR, FIR, there are many kinds of for example, the fume infrared suppression system I just did, and there are two kinds of suppression: the plume suppression, and another thing is cooling the ship's hull surface. This is the L1, L2, L3, L4, and when the uh, ship detection bias and so if our ship is easily a long range to find the enemy attack, the ship can be make ready to attack and some to launch flares. So it takes a operational advantage for this one. Okay. Okay. To reduce the underwater noise reduction, there are many noise makers, especially the engines and the generators. This comes from also the cylinder firing vibration and the various purpose of the fans, pumps like that, auxiliary and main drive motors and reduction gears the purpose. The problem is both the engine and the reduction gear and propellers. So to reduce the noise reduction, we have to design for non-cavitation propeller and some air bubble by using air bubble the basket belt in underwater ships, prevent the radiated noise in the sea, and the shock absorber and the vibrate absorbing mount under some noise making engines, and some shock hardening design. There are near field explosion, far field explosion is near field explosion is then near the ship, the line of torpedoes exploded. There are some shock wave and bubble effect. So the hogging and the sagging, they divide by two. So this is gradually used in our country also carried out this test 10 years ago. So we try to in the North North Korea attack our point in the West Sea. So they firing the torpedoes and two or many people died. After that, we design and research people try to make how to withstand this ship. Now, this time, all our ships are applied at the break of this trade. Normally, the ocean-going navy, the United States, the UK, and Australia like that, all they are only the field explorer. But in my country, warships are considered two things: near field and far field. For further systems. This is the power flexibility, the electric power system is there. This time, most of the warships are applied to electric propulsion because the power flexibility, high energy weapons are installed in these days. And the integrated mass systems, this is the past mass systems. So this time is the current mass system. All the inline ICS, standard systems, include the maintainability, we have some integrated mass systems. And the modular design for multi-mission, because there are many kinds of missions, but every mission we cannot make the new ships. So one ship, there are many kinds of we should carry out many missions by using modular design. And the AI combat system, as you know, the augmented AR system. And in this case, the unmanned marine system is very, very important because we have to save our life. And by saving our body, save our accept. So we they use the unmanned body system, SUV, GSV, UUV, and UAV. You can read these things and by using this. Why manned and unmanned teaming in Navy operation? In the developed countries, most of the countries introduce manned and unmanned multi-level operation. Why? Enhance the capability integration, operation efficiency, risk mitigation. You can read that. It's very important. And this is the United States Navy. They want host fleet. They say host fleet. They make the one team is the 20 ships. One commander ship is the DDJ 1000, and one giant trimaran, and 10 large unmanned surface vehicles, and 9 extra large unmanned underwater vehicles. So, if we go to send attack by this unmanned multi without sacrificing our crew, we can make successful attacks. Okay? This US United States dreadnought for target of 2050 multi-ship design like that. But at this time, I'm sure before 50, no, I think before 30, many things come true, I think. Okay. In my country also, man and unmanned multi for current Navy operation. We call the ghost command. I try to demonstrate some trivia for HHI design for Navy ghost command and HANA ocean design. Let's see the. Turn up the use of high technology.
No,
Uh-huh. the future, the soldier not fight, gamer can fight, okay? Any questions? Thank you for your attendance and, I hopefully just, yes.
이렇게 한국말
예.
이 전투기는 다음 세대에 대한 정의가 좀 나라마다 있는데
전투기요?
그나마 혹시 다음 세대에 대한 이런 것들이 주변 다음 세대에 대한 있는지
제들을 위한 고난의
그런 것들이 갖춰져 있어야 돼.
차세대 전투함. If you make one ships for future combat ship, all the design trends, if you plug in, then you can make some future ship. Because very complicated and very many things. So some that I just make small by using the short sentence of the trends, which design. This is the just trends. For example, the UK, they designed the future ship for target of 2050, but in this case, this is the 2024, but we can make short. Okay?
I know that there is a long-term plan to build Korean Navy ships because of the budget and so you need to have a planning for.
I think in the comparing the past, I think in the future, smaller one needed because we don't for future need not the big ships, so small the unmanned ship and the small ship because the save the money. So I think the money is not so important. What important is technology. This are our ships. The sea goes to command ship. They already started. Okay. My last sentence is that warship design and research we are very good job for your future and your country also. Okay. Thank you. Thank you very much. Nice. We have a different. Next up today. And price, yellow. Oh, this is expected. I'll send the code for normal schedule. Any questions, schedule?
So see you on Thursday.